Hello guys, myself Professor Vikash Katariya. In the last lecture we have seen that what is the operating system, how we can define operating system in different manner and different ways. Then we have discussed the essential properties of the operating system. Mainly we have discussed what is multi-program system and time sharing system. Then we had discussed real-time systems and distributed system, right? Sorry, time sharing system. Now in this lecture we are going to discuss two types of operating system. One is real-time systems and second one is distributed system. First is real-time system. Real-time system has well-defined fixed time constant. There is very important and very crucial operating system which based on the time constraints, right? Processing must be done within the time defined constraints or system will fail. That means if any system generate the correct result but it will not generate the result in a timely manner in defined time constraint, that means the system will fail, right? So real time design for the reason because we want to achieve the result in a defined constraints, within the defined constraints. It is often used as a control device in a dedicated application. A real-time system functions correctly only if it returns the correct result within its time constraints, right? So the query will be processed, query should be processed as the query generated, right? If the processing will take so many time or a delay, that means the result will not generated in a defined constraints, so it will not treat it as a real-time system if the answer of the query will generated after defining the constraints. So result should be accurate, result should be correct, and result should be in defined within the defined constraints, right? There is two type of real-time operating system. First is hard real-time and second one is soft real-time. Hard real-time system guarantees that critical task must be completed at the given time. It will take the guarantees that yes, we will done this task within a time. In other way, the soft real-time system, it will not take the guarantee that it will done task in a timely manner. So in a soft real time, a critical time gets priority over the other task and retains that priority until it completes, right? So this is about real time operating system based on the defined constraint. This is very important terms. Task should be done within the defined constraint, otherwise the given system will fail. Next one is distributed system. Distributed, that means we are making replica or resources in different system, right? So distributed system or loosely coupled system consist of a collection of processor. We have number of processor, we have number of computer system, and we are all the computer system are connected to each other, so indirectly processor are also connected to each other, right? Each processor have its own local memory like internal registers. The processor communicate with one another through the various communication lines such as high speed buses or telephone lines. So as I'm talking about the distributed system, that means there are different kind of operating system which scattered throughout the network, right? They are shared throughout the network and connected to each other, and every computer system or processor can be connected with a high speed buses or a telephone lines. Through the telephone lines they are connected to each other, and high speed buses, they can transfer the information from one processor to other processor, one operating system to other operating system, right? Distributed systems are desirable for following reasons. We design the distributed system because we desire something. One desire is we want resource sharing, right? We create a file and we want that these files should be shared between so many systems, so many processors. In that case we need to put our file into distributed system. So distributed system, suppose there are 10 system, design the distributed system, so our copy of my file will be distributed in 10 different system, right? Second goal is computation speed up. You can access any of the computer system. It is not required if the server is one. Let's have a look how the distributed system will work. Suppose we have 10 different system, each one has one processor, each one has its own local memory, right? There is one file which we want to share in distributed system, right? System 1, system 2, system 3, and so on, system 10, right? This is my file. This is the replica of file in server 2. This is the replica of 3 of my file in server 3. In that manner our file will be copied in different server, and all server are connected to each other through the telephone line, right? And their resource, they're sharing the resources. File is our resource in that case, right? So we are sharing the file from different server, so it is speed up the computation, right? Anytime if you want to access that file, that means we can access from there. Suppose this is my nearest server, so we can access the file from this server. Suppose I am the near about S2 server, so we can access, I can access this file from S2 server. So every server are connected to each other through the telephone lines with the high speed buses, and it will transfer file to different operating system and different computer system. That is why computation speed up is very rapidly. Reliability, I mean to say that if one distributed system gets damaged, that means we can't say the server S1 and S3 will not work properly, right? So there is no harming that it will work properly. We can access our file from server 3, we can also access the file from server S1. So this is reliable. If any one of the distributed system will damage or crash, it will not affect to the other server in other distributed server, right? So we can access from any other service, we can access our file from other servers. It is possible. That is why it is reliability. It is reliable. Communication, it is very fast communication. I can access our file from any server. Every server is connected to each other through the telephone line and will transfer our required file in very high speed buses. Right. So there is a concept of bus which used to transfer file from one distributed system to other distributed system. Right. For example, you can access www.google.com. Right. It will provide you home page of search engine. So you will receive a very fraction of time. You will receive the Google homepage in a very fraction of time. That means it is being the distributed system have scattered of millions of server and connected to each other that server. That's why you receive your homepage very rapidly. Right. This is what communication. Question number 4 is explain the hardware protection of the operating system. There is so many hardware protection, like first is dual mode operating system, input output protection, memory protection and CPU protection. There are 4 kind of hardware protection provided by the operating system. Dual protection, that means they are 2 mode. There is one is monitor mode and second one is user mode. If the mode bit is 0 means that is monitor mode, and the mode bit is 1, that means user mode. Then what actually is mode is operating system provide the facility to log in so many users in different mode. Right. Every user have its own username and password. If they put username and password in correctly manner, then operating system authenticate yes, user is authorized user and user need to change the mode. Right. That is why there is dual mode operating system. Dual mode operations provide us with the means for protecting the operating system from errant users from the one to another. One user cannot enter into the second user account. Every user have its own username and password. This is the protection mode. User mode and monitor mode are 2 different modes. Now how to identify there is user mode or monitor mode? So there is one bit which is known as mode bit, always attached with the hardware. Right. So every computer system have the different hardware, and every hardware has a single mode bit. If the mode bit is 0, that means it is a monitor mode, and the bit is 1, that means user mode. So this is dual mode operations. Second is input output protection. Input output protection, that means this kind of protection always for the restriction or prevent users from the performing illegal input output operations. Right. So you can use the keyboard or mouse for inputting, so you cannot put the wrong keyboard and wrong clicking. So this kind of illegal instruction should be protected by the operating system. Right. You should give the right input from the keyboard. You should give the right input from the monitor or any input output devices. Right. To prevent a user from performing illegal input output, or all input output instructions are defined as privileged instructions. Right. That is the meaning of input output protection. Second is users cannot issue input output instruction directly. Yet you cannot directly give the input output command to the input output devices. You need a system software, that means you need a operating system in between user and input output devices. So if you want to use the input devices, you must use the operating system in between. Similarly, if you perform the operating system output devices to prompt the message onto the console, to make the projection, to speak something in your microphone, and it will loudly forward by the audience to the speakers, so that will take care about the operating system, so users cannot issue input output instruction directly. Instead they must do it through the operating system, right? You just give the input, the rest of things will take care by the operating system. Third protection is memory protection. So protection is provided using base and limit register. There are two different kind of registers, which is very important. Base register tell us what is the starting address of the segment. Limit register tell us what is the limit of our segment, how much data we can store, how much byte we can store in a segment, right? Limit register is very important. It tells the size of the range, right? Size, I mean to say number of bytes. Okay, so memory protection. To protect the memory, operating system provide two different register. First is base and second one is limit. Base register holds the smallest legal physical address. Limit register contains the size of range. Let's have a look how the memory protection takes place. Memory protection done by two register. First one is base register, second one is limit register. Assume that there is code segment, base address is suppose 001, limit address is suppose 2000. So it is clear you can access from address 1 to 1 2000 address. That means it is clear we can access 2000 number of lines in code segment. We cannot access line number 2001, right? This is called memory protection, and this is performed by the operating system. I hope you getting my point. Base address is 4 times 01, limit address is 2000. You can access from address 1 to 2000. That means we can access 2000 number of lines. Starting from 1 and 2000, there is upper limit, there is lower limit. Sorry, there is lower limit, there is upper limit. In between 1 and 2000, there are 2000 lines number of code. We can access any one of line, but we cannot access which exceed the range of 2000, right? So we cannot access the line number 2001. It crossed the segment, it crossed the range of segment, right? Code segment. This is called the memory protection. Okay, and the CPU protection, it uses the timer. There is a clock pulse generator which generate clock pulse continuously, which count how many times, how many clocks taken by the process to complete it, right? The rest of question we'll discuss in the next video. Thank you very much.